So we'll solve for number 3. Find the volume of the largest right circular cylinder that can be cut from a circular cone of radius 6 centimeters and height of 9 centimeters. So we are tasked to find the volume of the cylinder. So what is the volume of cylinder? So volume of it is pi r squared height, right? So that can be cut from a circular cone. So our cylinder is inside the cone because it can be cut from a circular cone. So uh, we'll draw a cone. So let's say this is the cone, and there is a cylinder inside, right? So after this one, so after this one, we are tasked to find the volume, right? So we'll denote that this is uh, the radius of the cone is 6 centimeters. So the radius of this one is 6 centimeters, and the height of the cone is 9 centimeters. So this is 9 centimeters. 9 centimeters. So if this will be our cylinder here, so this is denoted as a smaller r, and this is also will denote it as the h, right? So if it is the h, so we'll denote this distance here as 9 minus h, right? So after this one, if we will draw a line here in the middle, we'll draw a line here. You notice that it form a triangle, right? It form a triangle in this one. So we need to maximize. The question is find the volume of the largest. So we need to maximize the volume of the cylinder. So V is equals to pi r squared. So V equals to pi r squared h. So we cannot differentiate it because r and h has this different variable. So we'll now find a way to relate these two. So by relating these two, we see that there is a triangle here, triangle formed by the cone. So by similar triangle, we'll solve that one. So by similar triangle, so this one 9 minus h, so 9 minus h over r is just equals to the bigger h, so 9 all over 6. So we'll solve this one. So we have 6 times 9 minus h is equals to 9r. So 9 times 6, 54 minus 6h is equals to 9r. So we have 6h. So 6h is equals to 54 minus 9r. So we have h is just equals to 54 minus 9r all over 6. So h is equals to 9 minus 3r all over 2. So we are having a value of h in terms of r. So we'll substitute it to the volume. So we have volume so that we can now maximize. So volume is equals to pi r squared height, and then V is equals to pi r squared multiplied by 9 minus 3r all over 2. So we'll distribute. So V is equals to 9 pi r squared minus 3 pi r cubed all over 2. So it is advisable to distribute all of the terms before differentiating. So dv. So we're now ready to differentiate. Dv over dr is equals to 18 pi r minus 3 pi all over 2. So derivative of r cubed is just equal to 3r squared. So we'll now equate it to 0. So 0 to find the critical points or the r. So 18 pi r minus 9 pi r squared all over 2. So simplify. So 0 is equals to uh, 36 pi r minus, just copy, 9 pi r squared. So we have 0 is equals to 36 pi r minus 9 pi r squared. So the remaining will be 9 pi r squared is equals to 36 pi r. So we'll divide both sides by 9 pi r. So 9 pi r. So the remaining will be, I will cancel 9 pi, cancel r, cancel r. So cancel pi r. So 36 divided 9 is just equals to 4, right? So 4. So at r is equals to 4. So at r is equals to 4, we'll now find the value of height. So h is equals to 9 minus 3 multiplied by 4 all over 2. So after this one, we'll have h is equals to 9 minus 3 times 2. So 4 divided 2 is just equals to 2. So 3 times 2 is equal to 6. So 9 minus 6 is just equals to 3. So take note of this one. H is equals to 3 and r is equals to 4. So we're now ready to find the volume, right? So for finding the value of volume, so we have largest cylinder. So we have volume equals to pi r squared height. So r is equals to 4 and h is equals to 3, right? So v is equals to pi, so 4 squared multiplied by 3. So by simplifying, so v is equals to 4 squared 16 times 3, 48. So 48 pi. So what is the units? It is centimeters, right? So cm cube. So this is now our final answer. So let's check if our answer is correct. So the answer is 48 pi centimeters cube, cubic centimeter. So our answer here is correct. So let's proceed to another number.